projects. In this video, we are going to explain about a project titled A Novel Software Engineering Approach Toward Using Machine Learning for Improving the Efficiency of Health Systems. So now coming to the introduction part, the convergence of software engineering and machine learning holds the potential to reshape the efficiency landscape of health systems. By tapping into the wealth of medical data and harnessing the capabilities of predictive algorithms, this novel approach offers the prospect of not only optimizing healthcare processes but also advancing patient care outcomes. As healthcare embraces the digital age, this approach stands as a beacon of innovation, pointing towards a future where technology and compassion seamlessly intertwine to build a more efficient and responsive health ecosystem. The synergy of software engineering principles with machine learning techniques opens door to automation and optimization, ushering in a new era of efficient healthcare delivery. So now coming to the objective part for this project is to harness the potential of machine learning to optimize the efficiency of health systems. By integrating predictive capabilities, streamlining operational processes, and upholding ethical standards, the approach strives to create a healthcare environment that is not only technologically advanced but also compassionate and responsive to patient needs. Ultimately, the objective is to revolutionize healthcare practices and enhance patient care quality in a digitally empowered era. By incorporating machine learning, hospitals and clinics can optimize appointment scheduling, bed occupancy, and staff allocation. This in turn reduces waiting times, enhances patient experiences, and maximizes the utilization of resources. The objective is to create a more streamlined. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first upload healthcare dataset. This initial step involves gathering a comprehensive dataset containing various health-related variables, patient outcomes, medical history, diagnostic results, and treatment outcomes. This dataset is the foundation for the subsequent stages of the process and should be representative of the health scenarios under consideration. Second, run health data pre-processing. Before feeding the data into machine learning algorithms, it must be pre-processed. This involves cleaning the data to remove inconsistencies, handling missing values, and transforming the data into a suitable format. Third, run machine learning algorithms. With the pre-processed data in hand, machine learning algorithms are employed. These algorithms learn patterns and relationships from the data to create predictive models. The selection of appropriate algorithms depends on the specific healthcare problem being addressed, such as disease diagnosis, patient risk assessment, or treatment effectiveness prediction. Fourth, predict machine learning model. So here machine learning algorithm is trained on the data set. It is ready to make predictions. New input data such as patient information and medical parameters are fed into the model to predict outcomes. For instance, the model could predict the likelihood of a patient developing a certain condition of the effectiveness of a particular treatment. Fifth, software testing. After obtaining predictions from the machine learning model, the software application that integrates these predictions need rigorous testing. This includes functional testing to ensure the software behaves as expected, as well as performance testing to verify its responsiveness and scalability. Sixth, accuracy comparison graph. In this step, the accuracy and performance of different machine learning algorithms are compared. Accuracy metrics such as precision, recall, and F1 score are computed to assess the reliability of the models. These metrics provide insights into how well the models are performing and which algorithms are better suited for the specific healthcare task. Seventh, exit. This final step marks the conclusion of the process. The exit phase involves finalizing the software application, documenting the procedures and results, and preparing for deployment. The application can now be used to provide valuable insights and predictions in real healthcare settings, potentially improving decision making and patient care. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as health dataset. In this we are containing .csv files. Over here are the dataset, and here this is the main Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. And now click on upload healthcare dataset button to upload the dataset. Here I am selecting this dataset folder, this dataset over here. Now click on open button to upload the dataset. So here you can see that the dataset has been loaded over here. And now click on run health data pre-processing for pre-processing the data. So here on this screen you can see that names of columns and in boxes values with minus symbols are not important, and only positive columns values are important, and ML algorithm will train only with positive values. So now closing this graph over here, and now click on run machine learning algorithms button over here. So here in this graph you can see that green color dots are the records which contains no disease, and red color dots are the records which contains disease. And this graph generated for all 154 test records. So now closing this graph, you can see that the ML prediction accuracy over here. We can see prediction accuracy of each algorithm, and from all algorithms extension, extreme learning, machine learning is giving good prediction accuracy. And now ML algorithms are ready with trained model. And now click on predict machine learning algorithm model button to upload new test records, and then ML will predict whether new test record contains positive or negative disease. So here I am uploading this dataset over here for testing, and now click on open button to upload the dataset. So here on this screen, for each test lab record, ML predict whether disease is positive or negative. And now click on accuracy comparison graph button to get the graph. So here you can see that the x-axis represents ML algorithm names over here, and y-axis represents accuracy of all those algorithms. And from this graph we can conclude that the extension EML is giving better accuracy. And now closing this graph, now click on software testing button to check all ML algorithms are working properly or not. So you can see that ML algorithms are working properly, and we will get test result as OK over here. So now coming back to the conclusion part, as we look to the future, the integration of software engineering and machine learning into healthcare is not merely a technological advancement, but a testament to a commitment to a more efficient and patient-centric healthcare ecosystem. By embracing this novel approach, we are taking tangible steps toward optimizing healthcare operations, enhancing patient experiences, and ultimately improving the overall health and well-being of individuals and communities. With the synergy of innovation and compassion, this approach offers a beacon of hope for a more efficient and effective healthcare future. The responsible use of patient data and the safeguarding of privacy remain at the forefront of its implementation. Striking a balance between technological advancement and ethical obligations is vital to foster trust among patients, practitioners, and stakeholders alike. Only through such responsible implementation can the potential benefits of this approach be fully realized.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.